Bismillahirrahmanirrahim. Welcome to International Research Class. For our discussion today, we will try to analyze the changes of the probability density function to the generate synthetics monthly rainfall. Our discussion today based on the one research article that published on the international journal with the title Generating Synthetic Rainfall on Various Time Scales, Daily, Monthly, and Yearly. This research article we have discussed for 2 or 3 times. For more explanation about this research article, you can join with the Rado Institutes with the comes to the www.radoinstitute.com, and you will find the clearly information about this research article. So we don't discuss deeply about this research article for this time. In this research article, there is one method to the generate synthetics monthly rainfall using the quantile function of the gamma distribution. So in this hour discussion today, we will try to use the sums 2-parameter distribution like Weibull and log normal and the gamma for generate the synthetics monthly rainfall. Okay, let's open our R programming. Okay, for the first time, of course, we will open our data. Okay, we try to choose the data. We use the daily rainfall data on Pekanbaru. Okay. Okay, we try to open our data. This is our data. Okay, we comes to the console. Now, we use the data, the daily rainfall on the Pekanbaru city. To show the heat of the data, we type the heat data. So we use the data. There is 4 column years. The first column for the years, the second column for the months, and the third column for the daily or the dates, and the fourth column for the hour data daily rainfall, starting in the 1990. Okay, the last data, we can type the tail data. Okay, our data, the last data in the 2000X on the December 31. Okay, the long series data, we have the 6,940 data. Okay, the first program that we can create, we will try to check for the each month. In this research, we must sure for the each month comes to the for the each years in this research. Okay, so that's why we try the program checks data. We give name the DD. We run our data, we come to console, so we can check DD. We type DD and then we enter here, and we can check for the each month like January. January comes to the all years in this research, starting in the 1990 until the 2000X. until the December. The December comes to the each years starting in 1990 until the 2000X. So for the all months in this research comes to the all years. Okay, this is very important because we are trying to cancel the losing data in the specific years. Okay, so after we check the all months, that comes to the all years, and then we try to take the monthly rainfall for the each month. Okay. In our research, we use the daily rainfall data and then to take the monthly data, we must make the summation for the daily data only for the specific month, for the specific years. For the example, we need the data for the January only and for the 1990 only. And then we need the rainfall on the January on the 1991 until we need the rainfall in the January for the 2000X. So in the R programming, we use name the start of sub 1. This is only for the try to produce the rainfall data in the January only. Okay, so we will use the January only and the DD. DD it's mean we have run the program DD to check the January comes to the each years. Okay. So we run our program and then you can check years the monthly rainfall data. We just only need the summation, the daily data for the specific month. In this program, of course, for the January only. So the missing data, we try to change to the 0. Okay, we run our data. We give name the data 1. So we run our data here. You can check the data 1. You type data 1, you enter, and then you can check here. In the 1990, for the January, we have the rainfall data around the 279.4. And then in the same month, for the 1991, we have the 150x.6 until the 2000x for the January, we have the data 255.6. So from this program, we have the data in the search column. Okay, so from the search column, we try to generate synthetic monthly rainfall by using sums 2-parameter distribution like Weibull, gamma, and log normal. In the log normal distribution, it's very easy to estimate the parameter. We only take the logarithmic natural for data and then take the mean and the standard deviation. For the gamma distribution, we use the moment techniques. You know that it's very easy for the gamma distribution to estimate the parameter using the moment technique. But different for the Weibull. For the Weibull, we need the program Newton-Raphson to estimate the parameter. So that why in this research, we try to make different the R programming to the estimate the Weibull distribution. Okay, for the more explanation to the Weibull distribution, you can join with the Rado Institute. There is some explanation about the Weibull program, and of course, we give the best art programming. So please join in the www.radoinstitute.com, because in this discussion, we don't discuss deeply again about the Weibull distribution. So this is a program for the Newton-Raphson to the estimate the Weibull distribution. Okay, we run our program. Okay, you can run here, and then you can check in the console. We can type the alpha. This is for the alpha and the beta. Okay, this is for the Weibull distribution. Okay, after that, after we are success to create the parameter of okay, we forget. Okay, wait a minute. In the Weibull, we must use the X. X is data in the search column. So for our programming, we the first time please give the X. Okay, for this one, give the X for the search column. Okay, because in the Weibull, we are use the X for the data. So we run again our program for the estimate the parameter of the Weibull. Okay, we run our program. So we can check again the alpha and the beta. Okay, this is for the Weibull parameter. And then after we success to the estimate of the Weibull parameter, we come to the next program to try to generate monthly rainfall. We only focus in the first month for the January. We will try to simulate 100 times. Okay, we try to simulate 100 times. We give the name, the program as simulation 1. It means the simulation for the January. And then this program will give the 9 output. The output this program is the months, the mean of the observed, and then the mean from the gamma distribution, and the mean monthly rainfall using the Weibull distribution, and the mean monthly rainfall using the log normal distribution, and the maximum observation is mean the maximum from the hour data, and this maximum from the simulation monthly rainfall using gamma, and then this one maximum simulation from the Weibull distribution, and this one the maximum monthly rainfall from the simulation using the log normal. So we have the 9 output for this our program, but you must remember we focus only on the January only. Okay, after we give the information January in the 100 times in our program using looping 4. The looping 4 is mean this program will try to simulate 100 times. So you can check here. This is alpha mean for the gamma. This is alpha, the parameter for the gamma distribution, and the beta for the gamma distribution. Use the moment technique. Please don't forget, for the Weibull, we use the H alpha. Okay, but for the gamma, we don't use the H. Okay. This is use the moment technique. Moment techniques is mean the mean power 2 divide the variance, and beta the variance data divide the mean data. In the log normal, we just take the logarithm natural data and then take the mean and then take the standard deviation. Okay, to generate the synthetic rainfall, we use the R gamma. R gamma in the R programming, it means we generate the data for the gamma distribution with the specific parameter. And the R variable, this is for the generate synthetic monthly rainfall, use the variable distribution. And this RL norm is the generates monthly rainfall using the log normal distribution. So after we understand about the all programming, we run our programming here. Okay, we run our programming and we come to the console. So we check the output of our generate programming. Copy here and paste here. And then you cancel the function and you enter. So you can check here. There are the 9 output in our programming. There is month. For January only, starting from this first simulation until the 100 simulation. Okay. For the first column is January only. For the second column, it means the mean monthly rainfall for our data. So it means we have the same means monthly rainfall for January for the 100 times. The all same. 274.3579. Okay. But in the third column, this is the mean of the monthly rainfall using the gamma distribution. So we have the 100 value. The all value is different for the means monthly rainfall in the January only using the gamma distribution. And the fourth column is the mean rainfall comes from the simulates using the variable distribution. In the fifth column, using the log normal distribution. And then in the sixth column, this is the maximum observation. It means the maximum for January only for the real data. So we have the same value for the 100 times simulation. And then in the seventh column is the maximum using the gamma distribution. In the X column, the maximum rainfall for January only using the variable distribution. And the ninth column is the maximum rainfall for January only using the simulation by the log normal distribution. Okay, after we have successfully run the program, of course, we must give the representative value for the 100 value for the each mean for the each 2 parameter distribution. So that why to take the representative from the 100 value, we use the mean only. So the sims 1 OK gamma, it means the simulation for the January using the gamma distribution. So we take by mean from the 100 simulation, we take the mean. Okay. In the search column for the gamma. And the variable, in the fourth column, use the mean. And this is for the log normal in the first column. And then in the second column is the for real data. So we give name this, the set 1 OK is mean, the mean from the real data. And if we use M here, it means the maximum. So maximum for the gamma in the 7th column. Maximum available in the X column. The maximum log normal is the 9th column, and the maximum for the real data for January only in the 6th column. So we try to run this, our data here. You run the data and you can check. Okay, like for example, we will try to check the output of this one. We Control C and put here Control V and you enter here. So the mean of the 100 simulation using gamma for the means monthly rainfall around the 276.7192. Okay, this is only for January. So for the all months, we use the same program, but we try to change the monthly only. If we give the 2, it means the February only. Okay, the February only. So we give them the data 2 for the February. For the text, the parameter of variable, don't forget, take the X for the data 2 in the column 3 only. So you run your data and then simulation 2. Remember that sim2 is mean the 100 times the simulation for the February only. Use the same program. Okay, use the same program for March and then until the December. Until the December, we still use the same programming. Okay, this one for the December. Okay, BLN 12, it means the December. We give them the start of Sep 12. Okay, and then don't forget, give them the data 12, and then try to take X for the third column only. We need this X for the estimate the Weibull distribution. After that, we give them the Sims 12 simulation 100 times only for the December. So we run all the programming. Okay, starting January until December. This is long program. Okay, we try to run the whole programming and then we check our programming. Okay, we run here. We come to the console, so we wait the program until the end. Okay, this one for February, and this one for the March, and this one for this April, and this one for the May, and this one for the June, and next for the July, next for the August, okay, for the 9th, okay, this is for the October, this is for the November, and the last time for the December. Okay, our program is very, very nice and a success to make the simulation for the all months in this research. Okay, after we success runs our simulation program, so we collect the all output using the simulation gamma. Sim gamma, it means you collect the simulation in the January, simulation on the February until the simulation on the December, use a gamma distribution. And sim Weibull is mean the simulation Weibull, and then you collect the simulation for January until the simulation for the December using the Weibull distribution. And the sims log normal is mean you collect the all information from the January simulation by log normal until the December for the log normal distribution. And then SEP is mean the observation. The observation is mean the mean rainfall on the January until the mean December. Okay. And if we use M here, it means the maximum. So M sin gamma, it means the all information about the simulation maximum on January using gamma until the maximum simulation on December using gamma. Same explanation with the M sim Weibull and M sim log normal. And M set, it means the real data, the real maximum from the real data starting on January until the December. Okay, we run all this information. We run all information. Okay, we run, and then we comes to the console. We can check the all information here. For example, if we want to know what is the simulation Weibull, we copy here and we paste and we type the enter, and then you can see there are 12 values for the monthly rainfall and start in the January until in December using the Weibull distribution. So if we are try to copy MSIM L norm, it's mean we paste here and we enter here. We have the 12 information about the maximum monthly rainfall starting in January until December using the log normal distribution. Okay, after we success to run the program, of course, we need to check which one is the best. Gamma, Weibull, or log normal, which one's the best? So we try to use the graph technique. Okay, in the graph technique, we give the X variable for the month. Of course, we representative is the number 1 until 12, 1 for January and 12 for December. Okay, we run X. Okay, so we run our plot. X for the month, steps for the means, the real means for the each month, for the hours real data. Okay, sim gamma, it means the simulation means monthly rainfall starting in January until the December using the gamma distribution. And sim Weibull, it's mean the mean of monthly rainfall starting from January until December using the Weibull distribution. And sim norm means this mean monthly rainfall by using log normal distribution. Okay, we try to create the plot and then we check the plot. Okay, this one the plot. Okay, you can check here. The lines ones, okay, the black lines, it's mean the mean rainfall comes the real data. The red ones is the mean monthly rainfall from the gamma. Blue one from the Weibull. And the green one, the simulation of mean monthly rainfall using the log normal. You can check yours. Okay. The green one is the bad distribution in the simulation rainfall because we can check the green ones is not the perfect in the capture the mean of real data for the each month. Okay, but different with the blue one and the red one. So it's mean the gamma and the Weibull best the distribution to generate rainfall, to generate synthetic monthly rainfall. To make the clearly which one is the best between gamma and Weibull, we try to using the mean absolute error. So in this program, we have the set mean for the real data. We have the sim gamma. The mean comes from the gamma distribution and the sim Weibull. Okay, and the sim L norm. So we take the mean absolute error from the gamma by using formula mean absolute. Okay, if we try to check the gamma, use the sim gamma minus seps, and then you take the MIAG. And then for the Weibull, we just change this one using the Weibull and change this by using W for Weibull. And then for the log normal, we try to change this using L norm. And then we try to using this is L. Okay, you enter here and then you type MAEG 2.x and MAAW 4 point and the MAEL. So we can show here the smallest one is the mean absolute error by gamma. So it's mean the distribution gamma is the best one to the generate synthetic monthly rainfall. Okay, And after that, we try to check the maximum rainfall. So we try to produce the plot again. Remember X the months, M set the maximum rainfall starting in January until December using the real data. M sim gamma, the simulation maximum using the gamma, and this maximum using the variable, and is the maximum simulation using log normal. Okay, we run our plot and then run here, and then you can check. Okay, the same result, the red one is a very close with the black one. It means the gamma is the best one. It capture the maximum rainfall data from our real data. So to check which one is the best, we can use the mean absolute error. So we have M set for the maximum starting in January until December by the real data. We have the M sim gamma, the simulation maximum using gamma distribution, and we have the M sim variable using the variable, and we have the M sim L norm. So we use the formula MA maximum mean absolute error for the maximum gamma. So we use the formula mean the absolute, okay, M sim gamma minus M set. Okay, you enter here and we try to use this M sim variable. And then we try to change here by W. And we put again for the log normal, L norm. And then we try change yes by L. Okay, we enter here. We try to check the flu, MAEMG. Okay, this one MAEMW. Okay, for this one MAEML. And you can check here the gamma give the smallest mean absolute error around the 140x.7574. So it means so very clearly our decision sends with the research article, the gamma is the best distribution to generate the monthly rainfall. So I think our discussion in the international research class, I hope my student can take benefit from our program today. Try to make the body of the research article, and we can discuss together, of course, together, to try produce the best research article. Okay, I think that's enough for international research class today. Rado Yendra, Rado Institute. See you again.